Now that we know what they're expecting. And I feel bad because on the past lab, like I did I did get through that. It's like I feel a little bit about stuff like, oh, have more taken out. No, it does. But
all right, welcome to the seminar. We're going to go ahead and start with a prayer from Bryce Barrett.
Our dear Heavenly Father, we're so grateful for this opportunity today to be able to meet together as civil engineers, those studying civil engineering, and to be able to learn more about the opportunities which are there for us. We ask Thee, Father, to bless us with Thy Spirit, that we may be able to learn and be prompted and inspired in our life choices to know what would be best for us to do for our future families and to be able to serve our brothers and sisters. We ask Thee to bless us to be aware of those who may be struggling, to be able to reach out and help them. And we say these things in the name of Jesus Christ. Amen. Amen.
Thank you, Bryce. Welcome to seminar. Tomorrow there is a field trip to the airport. I believe it's already filled up, but there was an attachment in emails to sign up for that wait list if you can't get on it. Meet here at 12:30, right up in the van. The senior banquet is coming up. Look out for Kim's email and RSVP, whether you can go or not. The closing swap is going to be coming up. That's going to be April 17th. April 17th is the last Wednesday of classes, the day before reading day. It's going to be out in the quad here. There's going to be hot dogs, volleyball. It's going to be at 5 p.m. There's going to be spike ball there. Just come and out and get time. That's free if you are a member of BYU-AFCE, and that's $5 if you are not a member. So if you're not a member, just go ahead, pay the thing, get in free this time, get in free in the fall, and you'll spend less. All right, our speakers today are from CUWCD, otherwise known as Kawakada. Brandon Rogers is from South Jordan, Utah. He graduated from BYU with a degree in chemical engineering. He's been working at Central Utah Conservancy Water Conservancy District for 2 years. During his spare time, he goes camping, plays sports, and does improvements on his home. And then Blake Bueller. He grew up on a dryland wheat farm in southeastern Idaho. He attended BYU, received his bachelor's and master's degree here under Dr. Nelson. After graduating, he obtained employment at Kawakata in Orem. He serves as a project engineer and manages the North Fork siphon replacement project as well as day-to-day activities associated with the company's asset management program. Blake and his wife live in Orem and are parents to a 3-year-old boy and a 1-year-old girl. Let's go ahead and have a warm round of applause for Blake and Brandon.
Everyone hear me? Yeah. All right, excellent. So as Jacob introduced us, I'm Blake Bueller. Brandon Rogers, one of my coworkers. We both work for the Central Utah Water Conservancy District. Sometimes we go by Central Utah Water, sometimes the district. There's quite a few specialty water districts in the state, so there's a lot of districts that you'll hear about. Today, we're having a joint presentation. We're talking a little bit about our company, asset management, the North Fork Siphon Replacement Project, as well as cheeseburgers. We'll tie that in eventually. So here's a map of the assets associated with my company. Brandon's going to talk a little bit more about the background of what our company does. Today I'm going to talk a little bit about the project I'm working on associated with the North Fork Siphon. So if any of you guys have ever been to Upper Stillwater Reservoir up in the Uintas, the project I'm working on is a pipeline located about 8 miles downstream of that reservoir. We've got some pictures of the North Fork Siphon. You've got the tunnel coming from Upper Stillwater, along with a pipeline going along a ridge line, followed by a siphon. You guys probably talked about siphons in your class. We've got about 700 feet of difference in head, over 300 pounds of pressure going through the siphon, and it's about 4,800 feet in length, 72 inches long, and it's made out of a material called pre-stressed concrete cylinder pipe, something you probably don't talk about a lot, but you'll learn a little bit about today. Another name for this pipe is embedded cylinder pipe, and I'll talk a little bit about the characteristics associated with that pipe and why I'm working on a project there. So the pipe itself transfers about 285 cubic feet per second. We get about 50,000 acre feet a year of water that goes through this pipeline. And just 2 years ago, we had about 80,000 acre feet of water. So there's a lot of water going through this pipeline. Brandon will talk a little bit about how much water we deliver. This is part of the Central Utah Project, so a lot of federal facilities. We're essentially a quasi-state agency. Here's a picture from the upstream side of the siphon, and I have a short video of the downstream slope that I'm going to show you in just a minute to kind of give you an idea of how steep it is. So there's slopes up to 70% on the downstream side and 55% on the upstream side. This is on the downstream side. If you look here, we've got a pipeline along the ridge and a siphon here. And the reason we're talking about it is we've done some inspections and come to some conclusions that I'll get to here in just 1 minute. Here's a video, a drone video, showing that downstream slope. I wish I could say I did that drone video myself, but I'm not currently certified. Sometimes, if you get an internship, they might actually certify you to do some drone videos if you're lucky enough to do that. We actually have 2 GIS, Geographical Information Systems analysts, that are certified to fly, and so we get a lot of drone videos. To give you a little bit more information about this project, originally installed in the 1980s, and I didn't mention previously, but this is about 40 miles northwest of Duchesne. I don't know if any of you are familiar with Duchesne. This is out near Anna, Utah, out kind of in the middle of nowhere, not a lot of people, but that's just where the water happens to be. The pipe itself, so this siphon essentially is pulling water in an unpressurized way from our tunnel, and then it pressurizes in the siphon. So it goes underneath a river, down a valley, and there's enough head, you talk about this in your classes, with enough energy that it can continue pushing that water through the siphon and to the next tunnel. And because of head losses, you guys talked about some of your classes, the elevation of the downstream tunnel is a little bit lower than the elevation where the water comes into the siphon. When I talk about a siphon, we're talking about pushing water from one mountain range through a valley and then up into another mountain range. Installed in the 1980s by Harrison Western Corporation, they put these 20-foot segments of pipe in. You can see, we got some nice black and white photos. You'd think it was from the 50s or 60s, but the Bureau of Reclamation, who designed this project and who was heavily involved with the construction, took these pictures. You have this cable and rail systems that they use to get the pipes in place. You can kind of see here they're putting some soil cement in. The hope was when we put this pipe in the ground that it would last for 70 years, but since I'm here talking about it, you can realize it hasn't lasted that long, just a little over 30 years. And the reason is because of some issues we've had with the pipe material. Now this pre-stressed concrete cylinder pipe I talked to you about is still used in a lot of areas. It's just good to be aware of some of the shortcomings of it and a lot of the problems associated with it have to do with the soil pipes. So essentially, you've got a steel cylinder that acts as a water barrier, and then you have a concrete core. This is the structural component that's wrapped by these pre-stressed wires. And the idea is with the pre-stressed wires and the concrete that the pipe gets both the properties of steel and concrete. On the outside, you have the cement mortar, and on the inside, you have cement mortar. And the purpose of that cement mortar is to protect the wires and to protect the water barrier. Now, the issue happens is when water gets inside of that cement mortar and starts to deteriorate those wires. If enough of those wires break, then bad things happen. Because of issues associated with those wire breaks, my company has decided to look into and evaluate this pipe. We've done a number of inspections. We do internal inspections. We also work with the Department of Interior, Bureau of Reclamation, and we hire some private consulting firms. You can see here, they have to rappel down into the pipe, something maybe some of you guys get to do someday. And they're checking for visual deficiencies. They have special little hammers that they hit, and they look for cracks. They also have this special equipment where they send electromagnetic frequencies through the wires to see if there's breaks. And in 2009, 2014, we did these inspections, found some things that weren't good. They found 11 pipe segments with notable deficiencies, and they found 13 segments where they said there were anomalous regions. That basically means unknown, which is not very comforting as the owner of the pipe. Hollow areas, places where there may be wire breaks, they're not sure. But there was one place in both studies where they found there were wire breaks. Let me show you some of the pictures. When this pipe fails, it fails catastrophically. You can kind of see those wires. Because of the pressures, like I said, we have over 300 pounds of pressure on our pipe. If this fails, it blows up kind of like a bomb, which is not good. You can see here, in Tucson, you have an 84-inch pipe that exploded. It cost $4 million to replace, and they lost over 38 million gallons of water. And then here in Miami, there was a 54-inch pipe that failed. It flooded lots of homes nearby, and it actually caused a crater in the middle of the intersection. So a 10-foot crater, 10 feet deep, 40 feet wide. There have been over 500 documented cases in North America since the 1970s of this pipe failing. So here's where I come along. As mentioned previously, I graduated in 2011. This is the first major large-scale project that I've been involved with. We hired AECOM. Some of you may have had internships with them or be aware of them. One of the largest engineering companies in the whole world. And they came in and did some additional inspections in 2016. What they found was not good. You can see 1,600 cracks, lots of spalls or areas where the cement mortar is coming away from the inside of the pipe. Lots of hollow areas, and the hollow areas were getting bigger from their previous inspections. They had access to the report. And at the end of the day, their conclusion was that the North Fork siphon was at the end of its remaining useful life. They provided a whole bunch of different discussions of things we could do to fix it. Carbon lining, replacing the worst sections. A lot of those were very expensive, and the problem with pre-stressed concrete cylinder pipe is if you replace one segment, it could just fail at the next segment. So we evaluated all the options, came to the determination that the path forward was to do a complete replacement of the existing pipeline, to leave it abandoned in place, and then alongside to build a new steel pipe, so a different material that could run the water through without the issues. So part of the project that's taking place over the course of 3 years is we're actually wanting to keep running water through during the project, and because of that we're doing some vibration monitoring and trying to make sure that the excavation of the new pipe, which is about 60 feet north of the existing pipe, will not cause damage. The cool thing with this project is we've brought on a contractor who has talked about using a cable crane. So instead of using your standard excavators, kind of doing switchbacks up the hill, there's a company based out of Austria, LCS, and they're going to come in and hook up a cable crane, and they can lift the pipes into place. Now this cable crane can hold pipes going up to 80,000 pounds. They've done these that have gone 10,000 feet in length, and we're pretty excited because it has a low environmental footprint, and the contractor was also able to demonstrate that it was less expensive than traditional methods. Unfortunately, that portion of the project hasn't happened yet, so I can't show you videos of that. But I do have a video of all the work that was completed in 2018. As I mentioned, this is a multi-year project. A lot of that's because we're in a canyon. There's a lot of snow, and so we can't continue doing the construction all year round. So take a look at this video, and then I'll turn the time over to Brandon. At the end of the presentation, we'll give you guys a few minutes. You can ask any questions about the project I'm working on or the stuff that Brandon talked about. One thing I failed to mention, there's actually a river that runs through here, and what happened is we used a copper or temporary dam, blocked it off, and routed the river around it. So they built this pipeline through the river, and now there's a river going over the top of the pipeline. And the other thing that I wanted to mention, you can see that there was a lot of snow in the end. Originally, the contractor was only supposed to go until Thanksgiving, but sometimes unforeseen things happen. The pipe, one of the pipe segments being carried from Mexico where it was manufactured, actually fell off the vehicle, so the driver got in an accident, the pipe came off, it damaged the pipe. They were supposed to get us a replacement in 2 weeks, and it took about a month and a half. So sometimes strange things happen, you have to account for that. But we have a really good contractor, Whitaker Construction, based out of Brigham City, and they were still able to get the work done this year. I did want to mention, as you may see, we have internships available. We post often through the Civil Engineering Department. We currently have an application available online. It goes through April 5th. I have some advertisements here on the table you're welcome to take. Before you go, I also have my business card. We do a lot of field work. We do a lot of job shadowing, learning about what operation and maintenance activities occur. We also help interns become very familiar with drawings and specifications and project management. And the interns that come on this summer are going to be helping me and some of the other staff do the project management associated with this project. We pay $13 to $15 an hour based on experience. If you have any questions about it, feel free to talk to me or Brandon after the fact. We'd love to have you guys apply. We currently have 6 interns, all of them from BYU, and we're probably going to have 2 or 3 positions. There are several former interns and existing interns here you may have met. You can talk to them if you're aware of that. I can see Alec was one of our interns. We've got Curtis here, and we've got Jared and some other of our interns here. So I'll turn the time over to Brandon.
Real quick, can everyone that has done an internship at Central Utah or is currently interning, can you raise your hands, please? Yeah? Okay. If you guys want to look around to those guys, if you have questions about how the internship is, I'll probably have time at the end to have a couple of our current interns come up here and talk about it real quick, but feel free to ask them or come talk to me or email us. Again, so the purpose of this is give you a little background. When I refer to the district, I mean the company for which we represent, Central Utah Water Conservancy District. And I'm going to go over asset management, a little background on the company, and what our role is. You'll get to know more about the infrastructure and the politics behind water that you ever care to know in the future. However, I found it very interesting, therefore you guys have to listen to me talk about it. And in addition, some of the principles we'll talk about, though you may not want to go into water or come and intern here, some of the principles are applicable to at least industry, if not to just personal lives. Asset management, for instance, it's worldwide principle that it doesn't matter what industry you go into, what workplace, whether it be at home or at work, asset management is a key principle in life to help you and organize and be responsible. So we are one of the 7 states within the Colorado River Basin, which is basically the Colorado River, all its tributaries that go, that feed into the Colorado River eventually, and Mexico as well. So how much time, sorry, are we stopping at 50? Is that when we're done? 50? Yeah? Okay, cool. And we have a certain allotment as Utah. It's been divided into 2 different, upper basin and lower basin. We have a certain allotment based upon how they agreed back in the day, early 20th century, on how much water we can take. So essentially, Utah's apportionment, portion of that is 1.3 million acre-feet a year. And we're not using all of that. And what's happening is, I don't know if anyone's heard of the Lake Powell pipeline that's going to be going in. There's a giant pipeline pulling from Lake Powell that's going to feed southern Utah. They're pulling from some of what we have yet to use of our apportionment. Otherwise, all the southern states get to use it, and they've been taking it. So, in the 60s, we were, as Utah was looking to get some infrastructure established for getting all of our water. That, if you didn't notice, back on this map, the Yep. This part is mostly not where the majority of the population is, but that's where the water is. So we need infrastructure to bring that water to the majority of the population in Utah. And so we were looking in the early 60s to get that, or 50s, as early as 50s and so on, to lobby to get that money to help us to establish that infrastructure. And in the 60s, after, and that was ratified, CUP, Central Utah Project, was ratified in that act, and we were allowed certain government monies to put in infrastructure into the ground that we could bring water from the Uintas and other places and distributaries to us using our apportionment of the Central Utah, of the Colorado River and its tributaries. And with that, the Central Utah Water Conservancy District was the leader and the lobbyist. They kind of took the lead, and therefore they were handed and led in Utah, as far as Utah goes, and its water apportionment in overseeing the allotment and the infrastructure and getting it distributed as far as the work as well. And in the 90s, because of inefficiencies in the government and getting construction done, there was a reorganization with the act on how the projects were enacted, and it's called Central Utah Project Completion Act. So I'm a dad, so I have to do that. So we currently have jurisdiction in 8 counties. We do something to do with water with those counties. And here's a little map of that. Here's a quick video. This is a treatment plant in Duchesne, which is an hour and 45. No matter how fast or slow you drive, it's an hour and 45 away from here. It's a treatment plant that we own and operate, and they pull from Starvation Reservoir. And you can see the dam on the left. Now the dam is a federal facility, it's federally owned, and which brings up a good point where a lot of our infrastructure, we were given money to put that infrastructure in. However, the government wants that money back, and so we need a taxing authority to get that money back from the citizens. So that's where you have Central Utah Water Conservancy District, or the district. They are the entity that taxes through your property tax, a portion of your property tax, to repay that infrastructure and maintain it. And then we also have some infrastructure that is owned by us, just us, and not federally owned. And the treatment plants are one of them. Now, I personally, we have multiple, different genres of work, but the majority of my work has to do with asset management, with the treatment plants and some of our conveyance and dams. And this is one of the treatment plants I spent some time during the summer. We spent a lot of time out here. And that's the intake down at the bottom left. This is a map, as you've already seen. And this is kind of a different way to look at it. We bring water from different parts. 2 major lake systems, Provo River system, and then we have, well, everything to do with Duchesne, bringing it out here in the IUNS. Number of dams, diversions, a bunch of large diameter pipes, tons of small diameter pipes, some treatment plants, and we have some hydroelectric power plants as well. These are some pictures of some dams that we operate and maintain. Bottom right is a diversion dam at the Provo River. You drive by it every time you go in Provo Canyon. Upper Stillwater is a really small reservoir, it's the head of one of our systems. Yeah, the neat thing about this one is it's a roller compacted concrete. It was one of the first and it was one of the largest at the time. China's since outdone us, but essentially if you don't know any background on roller compacted, I'm going to explain it. It's you do a layer of concrete at a certain moisture level or consistency, several feet thick, and then you lay it down. It almost looks like just hard, just wet dirt and gravel. And then you take a roller behind it, and you do another layer immediately after, and it's just one on top of the other. And there's no vertical reinforcement on this, and so each layer is just held together by, it's just weight. And so, that's all that's necessary for it. And the cool thing is when it gets full, you can see the dam kind of heave out. It flexes a little bit. It's pretty neat. And it spills. And it spills right about there. As you can see, we got a couple of leaks here. The system, that's okay. These are some smaller dams that we have at the head of the Provo system. Here's Jordanelle. We have a hydro plant down at the bottom here. And we do, yeah, it's a fun place to be. It's a really nice one. You just got to make sure you go during the summer because it finds its way to be the coldest place on earth in the winter. This is another view of a different dam. Now you just saw the video, the drone video. There's the treatment plant right there. This is a Starvation Dam. Another look at it. It's got a really unique spillway. It's pretty neat. It's kind of an infinity pool looking one. Here's another one. This is a reservoir that's well, it's above ground, but they buried it, so it made a hill, and it's in Napleton. It's a regulating reservoir, so it helps bifurcate flows, and it helps to regulate flows and pressures of downstream users. Yeah, look. Now this is kind of the end of Blake mentioned at the beginning kind of the high Uintas, upper Stillwater Dam ahead of that system. This is kind of the end of that system where it comes out. It comes out of the Spanish Fork Canyon and then either goes, it can go north to Provo and on from there, or it can go south to Santa Clara and elsewhere. This is another one of our dams that we have. This is the biggest reservoir that we operate and maintain. It's over 1 million acre-feet, Strawberry. Another dam, this is an earthen one. This is the inside of it. This is what kind of when I say diversion dam, this is kind of what we're looking at. This is one of our bigger ones. That's that. It's out in the middle of nowhere, and those are beautiful country. So interns get to enjoy being out there. This is kind of when we lay the pipe in as a kind of a look at the different pipe. This is the Spanish Fork Canyon that I was mentioning. This is them putting down a small pipe. Now, something neat, I want to go back to reference Blake's, the project that Blake is managing. This trench right here being supported by slide rail so it doesn't collapse in. When they did that river crossing, it was what? It was like 17 feet deep or something like that. It got pretty deep. That's pretty neat to see. This is inside of a tunnel. Now, every year we drain our systems, majority of our systems and tunnels, and we got to inspect them. So we ride bikes through these things. We go skateboards depending on it, and we walk down them, and we just look. And this is an outline. This is Provo Canyon. This is called Olmsted Flow Line. And when we divert down here lower from Provo, our allotment of the Provo River, it goes into a flow line or pipeline, and eventually goes either to a hydro plant or our treatment plant that is right here at the mouth of the canyon. Speaking of treatment plants, this is the one that you saw the drone video on. It's a smaller one. This is the one out in Orem at the mouth of the canyon. It's just up there on the hill. And this is one out in Vernal. It's all alone out there. This is another view of Strawberry Dam. Well, sorry, Soldier Creek Dam, which is the Strawberry Reservoir. So, just while we're watching this, down here, white tunnel, and that tunnel right there. When they did it into the mountainside, well, they were noticing that the water was seeping into the mountainside there that was supporting that side of the dam. And obviously, you know what happens when earth gets too heavy, it can slough off, and you don't want this water to go downstream really fast. So they drilled into the side of the mountain and then drilled a bunch of drains hundreds of feet into the mountain to help drain that. So, fun fact. Oh, another thing to give it a little bit more scale, the Teton Dam that failed was made by the same designers as this one. And so people started getting a little scared back in the day. Now, for the record, this dam is just fine. There is nothing to worry. But they did take precautions beforehand. That's one thing that's really neat about working with the district is they really do take safety, and they do spend the extra money to get the quality and safety that they need. So there's no reason to worry. Something that keeps us in check is the public eye. We are a government entity, so that helps us stay honest. Some fun stuff that I enjoy from my chemical engineering background is just the different mixes of water that this comes from. We have a reservoir, so the benefit of a reservoir is usually the water is supposed to settle out, and that allows, but it comes with different problems as well during the turnover season when the temperature changes and the water at the top layer goes to the bottom layer and vice versa, and you get some algal growth there, and that can cause some issues with the treatment plant. And then we have river, and then there's the springs, and also reservoir. So the vernal treatment plant that I told you about, they are the only ones in our district that pull from multiple sources, so they have to do some blending, which causes some issues with corrosion. It can cause some issues with corrosion, downstream treatment, as far as the cosmetic things. So if you ever smell funny stuff in your water, some of that can be as a result. It doesn't hurt you, just as a result of sometimes the blending of treatment or where it's so. This is a view of the hydro plant during construction and after construction. This is at Jordan Hill hydro plant there. There's a lot of convoluted stuff that happens in the district. It takes a long time to understand the inner workings, and I'm still learning a lot of it. For instance, the dam itself is federally owned, so it's federally owned, and so we only operate and maintain it, whereas the hydro plant, we went in a joint venture with a local utility, and we built that because there's just so much head. Why wouldn't we just use that energy, and sell it? So that's ours. Here's a look at one of the generators. Now, you may have seen this. It was destroyed last year. Methylpropane. This is a power box from the original Olmsted hydro plant. Now what's replacing is buried up there. And this is the new hydro plant that was built, trying to retain its historical look. And then we have, out in Heber Valley, we have a number of canals, pipelines, and pump stations to help with ag water. So we can deliver raw water for treatment by someone else. They can treat it someone else, but we can deliver them raw water. Or we can deliver ag water, or we can deliver treatment water. Now, our role is, with municipalities and us, we are a wholesaler. So we bring the water and then sell it however they want it to the municipalities or the organizations, and they can use it directly to the citizens or to their fields. This is kind of a couple of pictures of that Heber Valley stuff. This is a look out near out in Duchesne, the IUNS. Usually in the winter, people are really excited to get in the spring, and they just roll their eyes when we get another snow late in the spring or early in the spring. We love it. snowpack is where our water comes from, and it just makes us tickle when we see more water. We just love it, you know? Okay, so Geneva Steel years ago went bankrupt several times, and then in their final time they had to liquidate. And in that liquidation process, we purchased their majority of their water rights, their groundwater rights. And in so doing, basically we're creating redundancy. So we have a source of water coming from our treatment plant in Orem in this area. And it's always good when you have a critical process to have redundancy. For obvious reasons, in case one fails, you have the backup. So what we've done is we purchased these rights as a redundancy and plan for the future so that we can, we know the population is going to grow. We know Utah County, for instance, is going to get bigger than Salt Lake County. And we know that we're going to have 1 million people coming here. And so we have to stay, it's not good to be reactive as a water delivery company. You have to be proactive, just staying ahead of it. So the water that we use down at the Geneva, for Geneva Steel, those wells are a number of wells that we're drilling. This is kind of the drill rig. And they develop it, which is they put some casing in, they clean it out, and then if you can't see it here, but fun fact, in Vineyard's getting huge and it's growing fast. Like just on the other side of this picture, right here, just right next to it is an apartment complex. So the contractor, full knowing that we were going to develop that well eventually, just built a complex right next to where we're going to develop that well. And that's happened a couple of times, and we're having to develop some wells to stay ahead of the contractors as well, so that we can avoid the impact that it has on people. But this thing goes 24 hours a day, and it drills the well, cleans it out, and for months. And I mean, heaven forbid you have a child in an apartment complex or something, or even just trying to sleep or work nights or whatever. And this is after a well is fully developed. Just looks like that. You just put a little pump in there, and that's what the well houses look like, just down there. Now, last year, big fires. Now, big fires followed by a bunch of rain, and basically the only rain we had last year. And it sloughs off a bunch of debris because none of the vegetation is now holding that debris in. This is a look at the Strawberry River as it feeds into Starvation Reservoir out in Duchesne. And this is the same, again, there's a treatment plant pulling from this a little bit downstream. And it is just up here around that horn, and that point there. So all of this used to be bluish green, and now obviously it's brown because of all that debris that's washed off from the rain. As a result of this, we have to be proactive. We're seeing that vegetation takes a significant time to establish a decent footprint, and therefore we need to take precautions. And we're having to upgrade our treatment plant. Spend several $1 million to upgrade our treatment plant so that we can still deliver good water, because the water quality is going down here for a number of years, and it's in the foreseeable future, it's just going to, for up to the next decade, we're going to have to remediate all of this slough as a result of those fires. And we also have a water conservation program. In several years ago, 10 years ago or so, the legislature said that we had to have that all qualified water conservancy districts that have a budget greater than $5 million has to have an asset management program. So now you have asset management and all the big ones. And this is kind of a look at some of the stuff, just some of the budgeting we have to do on an annual or several time period basis, just for replacement. Asset management, important to know, it is very general. It is not just a financial tool that you use for managing your stocks and investments. It also has to do with life cycle of things that you own, cost, registry, a log of everything that you have, keeping all the data on it, maintenance, software tools, blah, 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 blah. And then, very considered assets because they gain knowledge that helps with the efficiency of the company. And as they gain knowledge, the idea is to mine that knowledge or to record it and those habits that they gain. So, as I stated, my responsibilities have to do with several areas: conveyance and treatment. Here are the pictures of those treatment plants. And then that's a circle around some of the conveyance. So those are tunnels and the siphons, pipelines, diversions. And the interest to you, if you're interested in something with Central Utah, is there's a chance that I would supervise that intern, and whatever I do, they would most likely do as well. So that's the interest. And then Provo River system, all this was a number of dams, pipelines that delivers water, both above ground on the slide area, hydro plants. Okay, we have to worry about life cycle. So an asset management life cycle, from the moment it goes into the ground or it's put into service, for how long do we think it's going to be? We have to track that. And here's a, let's see here, am I going to get that? Oh, this is a picture between my knees of me in a pipeline inspecting on a skateboard, on the back of a skateboard. We had to go several miles like doing that, and just looking at for different damages. You know, you have to consider, if this is too old, do you need to replace it? Or is it still working well? You have to do a fiscal analysis on it as well. We do estimating, so we see how much money is involved with everything that we own. We're currently estimating all of our facilities that we own to have a documentation of how much it costs. That merits how much we're charging people as far as property taxes and water use. And we're going to look at the list of items that we deliver to estimators so that they can track in drawings. It's a lot of detail-oriented work. Here's a look of some of the costs, like for instance this vault, which is just an underground concrete room. If you think about it, is you know, 1.2 million bucks. It's like more bigger than this desk, you know, concrete structure in here. Here's a look at Upper Stillwater Dam when it's spilling. This is, a lot of people love to see this. It's a really pretty thing. It's, if you look closely, you'll see a couple people go, "We did." No, you won't.
We've read it. We've read it.
The basis of everything is we have to log what we own. So we call that the registry. And when we log everything we own, we write down details associated with it. When we write down details, we put pictures. And when we put pictures, we also have, as Blake mentioned, a GIS portion of it. And so we draw everything so we know spatially where stuff is at. And we have drawings that we attach to it. We use the latest technology and cameras to take pictures. We support one another. As Kiko is here, you know, we help one another. Though we're on different teams, we try and help each other out. We provide, in asset management, we provide support to help guide through it's kind of a new process here in the U.S. And though there's a lot of data to sift through, we're here to help. And that's what our job is. We have an internship program, a very elite team. So we do inspections in the dirtiest, or I should say in the not so cleanest places. And this is me riding a bike down a tunnel. That dot is very misleading. At the very end of the tunnel, the light at the end of the tunnel is not close, by the way. It is miles away. It is very misleading. And it's very, very sad to find that out. So we also do, a big important thing is all the process we do, we try and document those processes so we can pass that on. If you want to stay after and ask any questions,